friends, in today's video we are going to rotate the servo motor using this touch sensor. So if we keep on touching this touch sensor, the servo will rotate continuously from 0 to 180, and by pressing this push button the rotational direction of the servo will get changed. You can see, right? So let us start building this project. So this is a program for the project. Here we are importing the servo library, and in this line number 3 we are initializing the servo object called my servo. And touch sensor pin is connected to pin number 2 and button is connected to pin number 3, and position is a variable which is initialized to 0, which is representing the current angle for the servo. Okay, and step value is a variable which is representing the movement speed. It means the servo will rotate each time by 15 degree, and direction is basically a binary variable which is initialized to false for the increasing angle and true for the decreasing angle. And in the setup section we are attaching the servo to pin number 9, which is the digital PWM pin. And make sure you should connect the servo to PWM digital pin and not any other ordinary digital pin, because the servo only accepts the PWM signal for its proper working. And the touch pin is going to be the input and button is going to be the input pull-up mode. And I will explain later on what is input mode and what is input pull-up mode. And initially the servo is at 0 degree. Now coming on to the loop section, in this section we are basically checking whether the button is pressed or not. So if the button is pressed, the condition or the logic on the button pin will be low and we are altering the direction. So if the current direction is clockwise, it will be changed to anti-clockwise and vice versa. And after that we are adding a delay of 200 milliseconds, which is called the debounce delay. And you can change this debounce delay. Basically debouncing is a problem which creates when the push button is pressed. Sometimes the single press is considered as two presses, and even sometimes the single press is not considered, right? So by adding this delay, we are ensuring that, or we are confirming that the button has been pressed and consider it as a single press. And if the touch sensor is currently active, we are moving the servo continuously, right? And in this if else condition, we are checking if the angle is increasing or decreasing. So if the angle is currently increasing, you remember false is for the increasing angle. So we are adding this step value variable to the position, which is for the moving forward. Either it can be clockwise or anti-clockwise. And this else condition we are subtracting the step value continuously from the position variable, and which is for the moving backward, which is just opposite of this forward. And we are keeping this position variable, which is the angle, in the range 0 to 180 degree. And in this line we are applying that position or the angle on the servo, right? So this is the complete logic for the project. Now let us start making the circuit connections, and before that, if you want to know the working of this touch sensor in detail, then you can check out this video. And in this video I have explained the entire working of the sensor and how our body's capacitance is also an important factor in its working. So let us connect the Arduino first. So we will take out two jumper wires from the Arduino, one from 5 volt and other from the ground, and connect this gray wire, which is a ground, into the negative rail of the breadboard, and this red wire into the positive rail. Now connect this servo. So this yellow wire is for the signal, this middle wire is for the VCC, and the last one is for the ground. So this is the signal wire, this is the VCC, and this is the ground. So connect the black wire into negative rail, red wire into positive rail, and this yellow wire will be for the signal. So connect it in the digital PWM pin. So 9 is the digital PWM pin, and you must connect the signal wire only to the PWM pin and not any other ordinary digital pin, because the servo only accepts the PWM signal for its working. Now let us connect this touch sensor. So you can see the middle one is the VCC, which means yellow will be going into the positive rail, and orange wire is for the ground, it will be connected in the negative rail, and green wire is the signal wire, so connect it in any of the digital pin, like pin number 7. Now we are left with the push button. So the push button can be connected in two modes. First one is input mode and second one is the input pull-up mode, right? And when you do not connect anything to the pin in the input mode, it remains in the floating state. Floating state means sometimes it can need high signal and sometimes it can need low signal due to electrical noise. So to prevent that electrical noise and random reading of high signal and low signal, we use an external resistor, right? This is an external resistor in both the cases. So this configuration is for pull up and this configuration is for pull down. So when you do not press this push button in the pull up mode, the pin remains connected to the 5 volt. right? So you can see this is a push button, two terminals on the front side and two terminals on the back side. So these two terminals are connected internally, and similarly these two terminals are connected internally. Okay, so this is the orientation for the push button in this diagram and also in this diagram. And by pressing this push button, the current flows from the pin through the push button to the ground, because the current always chooses that path which has least resistance, and this path is the one which has least resistance because here your resistor is present. And similarly in the pull down configuration, when we press this push button, the pin gets connected to the 5 volt, because here also this path is of least resistance. Okay, now coming on to the input pull up configuration. Here there is no pull down configuration, only pull up there is there, because the Arduino's internal pull up resistor gets enabled in this case. So the pin remains connected to 5 volt by default, and by pressing this push button the pin gets connected to the ground. So this is the difference between the input and the input pull up modes. Now I am going to connect this push button in the input pull up mode. So on the back side of this push button you can see two lines, right? This one and this one. So these lines are representing that these two terminals are connected internally and these two terminals are connected internally, but these two are separated from each other. So we will take out two jumper wires, one from this terminal and one from this terminal. One will be going into the digital pin and other will be going into the ground. So place this push button on the breadboard and connect one jumper wire from the digital pin and connect another jumper wire to the ground. So this is a complete circuit connections for the project. So if you have understood this project, hit the subscribe button and press the bell icon so you never miss my electronics tutorials. And if you have any doubt regarding this project, comment your doubt in the comment section and I will answer your queries. And I will see you in the next video.